So we actually accidentally ended the stream a little bit early, so we actually missed a lot of this stuff. So I'm gonna give like a very quick rundown on what we kind of missed. It was like a 20-minute thing, but I'll shorten it to probably about 5 minutes. So last we were talking about what we're storing locally on the device, the local state, and we're gonna store a couple of things. We're gonna store the device ID, and that's created at the start of the app if it doesn't exist. If it does exist, they'll just reuse it, and users can manually regenerate the device ID as well in case they want to refresh it. It likely won't be necessary, but we'll leave that option just in case. We'll store the room ID, and we'll leave it blank if they're not in a game, and then it'll be the room ID if it is in a game. So that's also can be used as a bit of a marker variable. So for example, if the game ID is blank or doesn't exist, then we know that they're not currently in a game. They can have the option on the screen to join a game or to create a game. And then we also have the role, which is hidden from other players, whether they're killer, villager, police, or whatever. And it'll be blank if they're not currently in a game. However, if most of the logic probably presumes that if they don't have a game ID, room ID, this is probably not being used. So even if it's not blank, it doesn't really matter too much. Then we have the list of players with the name and status and the stage. This is the exact same information that is available publicly through the Firebase real-time database. And this will be listened to, so it will refresh as the database refreshes. So as other players do actions, as the game moves forward, this will refresh from the server. And also any local settings, if there are any. So then we talk about the actions, which is what you can do. And we split that up into two different sections. One is the user actions, which is what can the user do. And then also the backend actions, which is what actions does your backend server have to do. So in terms of user actions, it's taken from the user's perspective. The user can create a game or join a game. They can set their name for games. So for example, they can set it as Chinese man, or they can set it as Nelson or whatever. They can take role-specific actions during the game. So for example, if they're a killer, they can kill one player at each killer phase, and detectives can check one player at each detective phase, and villagers can vote for one person at each discussion and voting phase. So actually, when we got to here and we started writing this down, we realized that we don't know if the player already took their action or not. So therefore, we actually went back up to here for action taken, which is a Boolean variable. If it's false, the user can still take action for that turn if they're eligible to take action. Otherwise, it'll be true. And in retrospect, I actually don't like this because you'll have to remember to always set actions to be false if they can still be taken, and true otherwise. But I kind of prefer the other way. If it's, for example, action available, in that case, it's true if it's still available action, and false otherwise. Just this way, the whole like false means no, true means yay. That way, it's a little bit easier for developers to understand and a little bit harder to mix up. Because remember, you might have a lot of different code. You might have a lot of developers working on your project. So this way, you want to make sure that your code is as readable and as maintainable as possible. And that kind of goes into the whole design phase where we start off with the data that's available, and for a couple of reasons. One is we know what data is available when we look at what actions to be created. We also look at what data needs to be there for those actions to complete. So as we're looking at the user actions, we're thinking, okay, what data is needed to complete this action? So when we got to here that they need to have a role-specific action during the game, then it was like, oh, we don't have a way to keep track of that, so we should keep track of it, and therefore we update the data. And as the data updates, it was like, okay, now that we have this data, is there anything else in our actions that needs to be updated to account for this data? Other things that I am now thinking of is that actions here, we can set their name for games. So for local state, we also want to keep track of their name. Not just the list of players and their names, but also like what is our name. So we can just put that as name. And then we also want when joining a room, if name exists, give error and prevent from joining. Because otherwise, if there's like 5 rays, then which ray do you kill, right? Or which ray do you check? So back to actions. Taking role-specific actions during the game. We know that's possible because we have the different roles for the player, and we also have the stage that the game is at. And then we also have the device ID that defines the player. So with those pieces of information, we can actually take that action. So for each action, when you write down the action, you also want to think about what does it mean in terms of the data. Do we have the data required to complete this action? And what data does this action give the application? And then end game if leader and leave game if not leader. So we also have to add in who's the leader of the game. And then I was thinking, do we want the leader to be publicly available here in the RTDB or accessed through a server? Then upon further thinking, the leader can take administrative actions. And that doesn't change throughout the game. So let's not use RTDB for that because RTDB can be a bit on the expensive side. So we'll keep that in MongoDB. And it's a good place for it because when you take an administrative action, it goes to our server first. It doesn't ever hit directly to the public database. And that server can, at that point, can check, is this player authorized to do that or not? And then same thing for leave game if not leader. Anyone can leave game at any time. We do want to have in local state whether it's a leader or not. So here we can probably have name, status, and then leader name. If leader name is same as current name, then you are the leader. So this way we don't have to keep track of we don't have to map, for example, the device ID back to a player name when we want to tell which player is which user is the leader. We just have the name. But because the names are unique as they join, their action on the device can just be checked by just having the leader name. Although when they actually take the action, having the check on the device ID is probably better. So here when we store the leader, where's leader? MongoDB, the room. Leader ID is the device ID of leader. So when they actually take an action that requires authentication as leader, then we're going to check to make sure that they actually have that permission by device ID, which is a lot more secure than the name. We do have checks in place to make sure that two players with the same name joins, but if we have 2 things that identify a player and both are unique, let's just go for the little bit more hidden one, just in case we mess up security somewhere. So those are what the actions the user can take. Now we want to look at what actions that the server can handle. So in terms of what the server can handle, we want to make sure that the server can respond to when someone wants to create a game. It requires the player name and the device ID in order to create the game. Given this information, we have all the information we need to actually create the game, because everything else that's stored here, given these 2 pieces of information, we can create all of that. Because the IP address, for example, is taken off the server request. You don't need to have that passed to the back end. It's kind of automatic. But we do need the player name and the device ID, because those are 2 user set pieces of information that we don't have. Everything else, like stage, it'll be the default starting stage. The roles that gets populated when the game actually starts, all that stuff. Oh, start game will be the next one. So start game, and that will require the device ID. And the reason for that is that way only the leader can start a game. Because once the game starts, he can't add any more players. We don't want just any random player clicking start. And then it'll return true if success. And then the game will have started. So we want to be able to join game. Again, we need the player name and the device ID. But we also need the room ID of the game that they're going to join. And then the role-specific actions. So it'll return result if success, false otherwise. And that's going to be actions like, for example, if they're police, they can check a player every turn. Or if they're a killer, they can kill a player at their turn. Or they can vote for a player to be kicked out at the village discussion round. And all players have access to that, they can vote once. And we're thinking about the voting, we suddenly realize that, oh, hey, we don't have anything to keep track of how many votes each player has. So we actually went back up here and we added that for votes. For how many votes are there against this player. It's a debate of whether we want to keep track of who voted for who and therefore tally up the total votes dynamically. For example, if we have an array of votes or an object of votes, each player name and then who they voted for, we can easily find out who voted for Tom by just looking through that object and looking for who voted for Tom and adding that up, and that's how many votes against Tom. But if we don't really care about who voted for who, we just need to know how many votes are against the player. We can just have that as a counter variable. One of the benefits of that first method would be we also keep track of who voted for who, so you can't vote twice or you can change your vote. And what that means is, for example, we voted for Tom at first, you can change it to voting for Cindy. And therefore, it'll cancel your vote for Tom and then it'll change your vote for Cindy. The downside is, to get the tally of votes, you would need to kind of loop over that object and tally it up each time you want to get a total. So I'm actually leaning towards keeping track of who voted for who. Yeah, actually, we should keep track of who voted for who, because that way you can change your vote during discussion. Yeah, let's keep track of who voted for who. So the reason why we keep track of the player name and not the device ID here is when we want to push this to the public. For example, we want a list of who voted for who also available publicly, then we don't want to have that mapping. Otherwise, every time we get a device ID in the voted for, then we'll have to do a lookup on, so what's the name of that player, because we never want to pass the device ID of any player other than themselves to any other player, because that's a big security thing. It just ruins the whole security setup. We also want to, I guess, prevent too many lookups. So if it's the name, you just need to store that directly into the database on both the back end and the front end. With the device ID on the back end, we also have to do a lookup to get to the name in order to the front end. So here we'll also do a voted for against. So that way that it's publicly seen who they voted for. And then we can tally that up as a total for the UI on the client side. So that's the role actions. And then you can also end the game and leave a game. So again, if you're ending the game, you have to be the leader of the game. If you're leaving the game, anyone can do that unless they're the leader. If they're the leader and they end the game, then it kind of ends the game for everyone. So that's it for the data and actions video. Here we're going to, for our next video, we're going to talk about the user interface and the skeleton. In the video after that, we're going to actually start coding. I know it's a lot of planning and a lot of talking during these videos, but we have to make sure that we have good planning in order to know what to code and how to code it. Because you don't want to have code that you're going to be like, oh crap, I can't use this code after all because it's not the right code for the purpose. So by planning in advance, you save yourself actually a lot of time later on in the coding part, and also gives you a big picture view of the entire game itself. So that way you know as you're coding what other pieces of the puzzle that you want to be looking out for. But eventually we'll get to actual coding videos where we'll be coding the front end user interface and mobile app in JavaScript, React Native, and then we'll be coding the back end for Node.js Express as an API, and we set up the databases and all that technical stuff. But for now, we're just talking about like the planning and design phases. Hope you liked the video. Drop a like, drop a subscribe, ask your questions in the comments, and hope to see